Right. Hey, ladies and gentlemen, this is Miss Humbert, and we're going to do Unit 4 Notes 4. So today we're going to talk about squares and rhombi and the differences between the two. So first let's start by talking about a rhombus. So rhombi is the plural of rhombus. So let's start taking a look about rhombus. So a rhombus is a parallelogram with four congruent sides. So I'm just going to use that. Remember, that's the symbol for congruent. If you want to write out the word congruent, that's fine too. Okay, since a rhombus is a parallelogram, then a rhombus also has the following properties. So let's just remember what that means. The opposite sides are congruent, and they're also going to be parallel. Those vertical two lines represent parallel. Opposite angles are also going to be congruent. Consecutive angles are going to be supplementary. And the diagonals are going to bisect each other. Okay, so all of those right there are properties of a parallelogram that also apply to a rhombus because a rhombus is a parallelogram. In addition, when you're dealing with a rhombus, your diagonals are perpendicular. So they're going to form a right angle, okay? So they're perpendicular. So all of these are right angles in there. Also in a rhombus, each diagonal bisects the opposite angle. What does that mean? Well, that means that angle 1 is going to be congruent to angle 2. Angle 3 is going to be congruent to angle 4. Angle 5 is going to be congruent to angle 6. And angle 7 is going to be congruent to angle 8. So all of those are properties we can use when dealing with a rhombus. So let's go ahead and let's take a look at number 1. So given a quadrilateral ABCD is a rhombus, we need to find the following. So the measure of BCD. BCD. Right there is 64. Now it wants us to find the angle measure of BAC. Well, keep in mind that if this is 64, then this whole thing has to be 64. We're looking specifically for BAC. Now remember what we talked about on the previous slide, that these two angles are equal to each other because the diagonal bisects it. So to get what BAC is, all we have to do is take 64 and divide it by 2. When we divide it by 2, we get 32. So that's your final answer for that first part. For part B, if AB is length 2x plus 3, find BC. Now remember, in a rhombus, all of your sides are equal. They don't have to be opposite to each other. All of your sides are equal. So 2x plus 3 is equal to x plus 7. So then let's go ahead and solve this for x. So we're going to subtract x from both sides, and then we get x plus 3 is equal to 7. Subtract that 3 to the other side, and you get that x is equal to 4. So that right there is your final answer for part B. Let's continue on and learn a little bit about a square. A square has 4 congruent sides and 4 congruent angles. All right, so basically a square is a rectangle and a rhombus. Okay, so we're kind of learning to classify our quadrilaterals. So let's do a kind of a neat chart that'll kind of put that together for us. So right angles, for right angles we're talking about rectangles. Okay, for congruent sides we're talking about a rhombus. And then what's both of them? Overlapping for both of them is a square. So a rectangle always has to have a right angle. A rhombus always has to have a congruent sides. So what has both of them? A square. So let's take a look at these last couple of problems. So for number 2, it says the diagonals of rhombus W, X, Y, Z intersect at V. Use the given information to find the measure or value. So W, Z, X. This angle measure right here is 39.5. Well, that means that this guy right here is also 39.5. Now, what else do I need to know? Well, it also wants me to find the angle of X, Y, Z. So this angle here and this angle here are consecutive angles. So if we think back to the properties of a parallelogram, consecutive angles are supplementary. So that means that 39.5 plus 39.5 plus, we'll call this x, whatever that angle is, has to measure up to 180 because that's the definition of supplementary. So 39.5 plus 39.5 is going to give me 79 plus x is equal to 180. Solve that for x and you get that x is equal to 101. So that angle measure is 101. Let's take a look at part B. So part B says that WX is going to be 8x minus 5. WZ is going to be 6x plus 3. Again, because this is a rhombus, all of our sides are equal to each other. So 8x minus 5 has to be equal to 6x plus 3. So now we want to take this positive 6x and get it over to the other side. So I'm going to just subtract 6x from both sides. So I get 2x minus 5 is equal to 3. Now I want to get that minus 5 over to the other side, so I'm going to add 5 to both sides, and I get 2x is equal to 8. Divide both sides by 2, and I get that x is equal to 4. So that's your final answer for part B. Last but not least, let's take a look at number 3. WXYZ is a square. So that means it's also a rhombus and a rectangle. If WT is 3, find each measure. So WY has to be this whole length. Remember when we talked about rectangles, how these two had to bisect each other. So it had to be 3 and 3 on both sides. So the length of the whole diagonal then is 6. So then TZ, well, when we're talking about a rhombus, our diagonals, or a rectangle, sorry, our diagonals also have to be equal to each other, which means TZ also has to bisect to get 3. Next, let's take a look at our angle measures. So it wants to know the measure of angle WTZ. Well, remember a property of a rhombus. So when we're talking about rhombi, we know that the diagonals hit each other at perpendicular. They're perpendicular to each other. Since they're perpendicular to each other, they all have a measured angle of 90 degrees. Then let's take a look at WYX. Well, remember what we also know about rhombi is that the diagonals bisect that angle. So that means that this side is equal to this side. Well, since it's a 90-degree angle, all we have to do is take 90 divided by 2, and we get a measure of 45 for that angle. So that concludes your short note video for today. Please show me your note sheet when you're done. Thanks for listening.